Paul's homework assignment in lesson 26 was to draw a floating potato chip on the OLED display. The floating potato chip is actually a Lissajous curve. Lissajous curves are a family of curves which can be described by the parametric equations on the screen, where a and b are often set to 4 and 3 respectively, and p and q must be chosen so that p divided by q is always greater than 0 and less than 1. In other words, p is never 0 and always less than q. We should be able to plot Lissajous curves as easily as we plotted a circle in the last assignment. Having the plot rotate is a bit of a puzzle. We'll be plotting the Lissajous curve equations. The following webpage describes Lissajous curves in more detail. On that website you can see what a wide variety of curves can be generated just by altering p and q. And we'll be giving our user the opportunity to change p and q values in our program. The website above contains Lissajous curves generated with a variety of those p and q settings. Within the limits of the OLED display, we should be able to duplicate those curves on the OLED. We start by importing pin I2C, SSD 1306 I2C in the Python math module. Then we define the I2C parameters for the OLED display. In this case, we're using channel 0 for I2C, and SDA is connected to GPIO pin 0, and SCL is connected to GPIO pin 1. That 400,000 Hertz frequency is a default. We'll create some variables to hold the OLED height and width, and then create the display object DSP by providing the width, height, and the I2C parameters that we figured out earlier. We put a title in the center of line 0 and underline it with the hline function. We create two variables, cx and cy, which will help us to specify the center of our plot area. Here we specify the a and b parameters used in our equations. These are often cited as a equals 4 and b equals 3, so we'll use those values. We specify x scale and y scale parameters, which help us to fill the plot area as much as possible with our curve. We're going to be plotting the Lissajous equations shown on the screen. A and b are preset already. P and q are going to come in from the user. As it turns out, changing c gives the appearance of rotating the curve, so we'll generate c in a loop. We start by clearing the blue area of the OLED, then we prompt the user to enter p and q in the Thonny shell. We clear the display once valid p and q values are entered, and we display those values. We cycle through values of c from 0 to 360, and for each value of c, we'll erase the plotting area, display the value of c, and draw the Lissajous curve in a for loop that covers all the possible values for t. And here's how it looks. So that's it for lesson 26. I hope you liked it. Hit the subscribe button if you feel like it. Don't forget the notification button. Give me a thumbs up if you enjoyed the video. Any and all comment is welcome, and I'll talk to you during the next assignment. Bye for now.